Now, there's a sequel to that little story that I told you last time about how the elements can form ions and how we can know how they can form ions and how we can figure out with a charge on the ion and all that. And you remember last time we were looking at the Bohr model of the atom, which we've been looking at for a long time now, and we saw that in this column all the elements have just one electron in their valence shell, that outermost shell. 2 electrons here, 3 electrons here, 4, 5, 6, 7, 8, and so forth all the way across. Well, it turns out that looking at those kinds of electron configurations can help us also figure out how the element might want to share electrons. So I want to look at that a little bit, but first I have to introduce something called a Lewis dot formula. Very, very simple, probably the easiest thing you're going to learn all year. To draw the Lewis dot formula for an element, we write the element symbol. So let's just start with lithium. How's that? And next to it, we put the number of dots that represent the number of electrons in the valence shell. Now in this case, over here, there's 1 electron, so the Lewis dot formula looks like that. Now, if we were to go on to something in this column, let's just pick magnesium, the Lewis dot formula would need 2 dots because there's 2 electrons in the valence shell. So we write 2 dots like this. And if we go over to this column, then let's just pick aluminum, we would have 3 dots. You getting the hang of this? Carbon would have 4 dots, and anything in that family would also have 4 dots. Let's do phosphorus, that would have 5 dots. Let's do oxygen, that would have 6 dots. Fluorine, 7 dots. And finally, let's just pick argon as an example, and we'll do 8 dots. So those are Lewis dot formulas. And in terms of the arrangement, just by convention, and actually there is good reason for this, which we won't get into today, we don't start doubling up until we've got 1 dot on each side, and then we can start doubling up. Because electrons will tend to not double up until they have to. Long story, we'll talk about that later. But as you can see, it's very easy to do. 1 dot, 2 dots, 3 dots, 4 dots, 5, 6, 7, 8, and that's your Lewis dot formula. Now, let's look at how we can use these to make compounds. We haven't talked about compounds too much. In this scenario, our goal is to make sure that when we finish writing the structure, all the elements have 8 electrons in their outer shells. And they will count all the electrons that they're sharing. So sometimes 2 atoms are both considering the electrons to belong to them, and that's okay. That's what it means by sharing. Now, 8, that means these elements want 8, and these elements want 8. Remember, these elements only want 2, and we're not really going to see anything for reasons that we talked about before. Those are not going to react anyway. But hydrogen only wants to have 2 electrons because it only has 1 energy level, and that energy level can only hold 2 electrons. So let's erase this and try a couple of simple ones. Let's do ammonia. So the common name for this substance is ammonia. We'll talk about how to do the official name for it another time. So nitrogen has 5 electrons. And I told you last time that nitrogen often doesn't form ions because it takes so much energy to gain 3 more electrons. That's just a lot of electrons to transfer. So it will tend to share electrons. Now we've got 3 hydrogens to work with. That's what that little number 3 says. It tells us that there's 3 hydrogens. And each one of them, let's line them up so we can look at them. Each one of them has 1 electron, and it really wants to share another one. Or it wants to lose. So if it was going to form an ion, it would probably lose that electron. On rare occasion, it gains 1, but not too often. Usually it will lose that electron because that just takes less energy, but sometimes, actually often, it will share instead. Now look over here, nitrogen would like to share 3 more electrons, and there are 3 hydrogens, each eager to share their electron. So that's what we're going to do. We're going to take these hydrogens, let's move this one over here, let's move this one over here, and let's move this one over here. So I'm running out of space here, but this is what I'll do. We'll take the nitrogen with its, we call that an unshared pair of electrons. Ah, now look at that. So this hydrogen thinks it has 2 electrons and it's very happy about that. This hydrogen also thinks it has 2 electrons and it's very happy. Same thing with this hydrogen. Now how about nitrogen? How's it feeling about life? Nitrogen thinks it has 2, 4, 6, 8, which makes it very happy also. So ammonia is a nice stable molecule because all the atoms have what they need to make them stable. Ammonia's got its 8, each hydrogen has its 2, and that works. Let's look at water as another example. Pretty familiar with water. All right, so what does this tell us? That little 2 tells us I've got 2 hydrogens and only 1 oxygen. So drawing them separately, we know that oxygen is in this column and it's got 6 electrons in it, so that's the Lewis dot formula. Each of the hydrogens being over in this column have only 1 electron. And look what's happening here. So oxygen would like to share 2 more because it would really like to have 8. Each hydrogen wants to share 1. So very similar to what we did before. We'll take this hydrogen and bring it over here. Take this hydrogen and bring it over here. And we can write it like this. So oxygen has 2 pairs of electrons that it's not sharing and 2 pairs of electrons that it is sharing. So similar to what we did before, we can evaluate how everybody's feeling about life. We've got hydrogen thinks it has 2. This hydrogen thinks it has 2. Oxygen thinks it has 2, 4, 6, 8. And again, everybody's happy.